A good day to everyone who's watching. In our lesson today, we are going to talk about algebra. So in algebra, we are going to begin by forming algebraic expressions. For example, my example one there, John took a number, added 4 to that number, and then multiplied the result by 3. So now we are going to let that number be any unknown. Then we try to form an expression mathematically. So when I let that number to be m that John took, so we add 4 to that number, then multiply the result by 3. The result is 4 plus m. So I'm going to multiply this one by 3. So my expression is 3 times m plus 4. So you shouldn't forget, or this shouldn't be confusing you. If someone writes m plus 4, then a 3 there, that one also means multiplication. Some other person can write m times into brackets m plus 4. Some other person can write m plus 4 into, some other person can open the bracket 3 times that, then this times that, to have 3m plus a 12. Just as simple as that. So my example 2, the length of a right angled triangle is twice its hypotenuse, and the height is 4 meters shorter than the length. Find the total distance around the triangle. So I'm going to first draw my triangle. This, the base, I'm going to take it as the length now. This one here is the height, and then the hypotenuse there. So they are saying that the length of a right angled triangle is twice the hypotenuse. If my hypotenuse is x, that means that this length of mine is going to be 2 times x. Then the height is 4 meters shorter than the length. So if the length is 2x, you need to deduct 4 meters from the 2x to get the height of the right angled triangle. So this becomes 2x minus 4. Now they want the total distance, that is, you add the hypotenuse, you add the length, you also add the height. Total distance is going to be equal to the x plus the 2x plus 2x minus the 4 there. These ones are like terms, the x, they are like terms. So when I add them, I'm going to have 5x minus a 4, and this is the total distance. The 4 here had units of meters. I'm going to give it units of meters there. So our next subtopic, we are going to simplify algebraic expressions. So after looking at how to form those expressions there, then now we can see how we can simplify them. That is, opening brackets, dividing them, adding them when they have fractions, and so on and so on. So example 1 here, we have been told to simplify the following. Number 1 is the 4a minus 6b plus 2a plus 7b. So you need to note here that we are going to be doing operations on the like terms, either addition, subtraction, multiplication, or division. Then you also need to differentiate between non-like terms. For example, if I have 4a and some other person is having 3a squared, these two here, they are not like terms because the power of the unknown a is different, so they cease to be like terms. So first I'm going to bring the 2a close to the 4a because the a's, they are like terms. So that is 4 plus 2a, then minus 6b, then plus 7b. So what I get here after adding is the 6a. When I subtract here, negative 6b plus 7b, that one is going to be positive b there. So example 2 there, we have 4x plus 3x minus 7. This example 2 here, the coefficient outside this bracket here is 1. So 1 times anything that is inside there is going to be the same thing. Again, the coefficient 1 has a positive there. The positive does not affect what is inside the bracket there. So this is going to be 4x plus 3x minus 7y. So when I add the like terms, that's going to be 7x minus the 7y. Now suppose this example had a negative there. So this negative 1 is going to affect the signs of every term that is inside that bracket. So here we would have 4x minus 3x, then plus 7y. Why? Because this is a negative 1 is multiplying a positive 3x to get a negative 3x. Then a negative 1 is multiplying negative 7x to get a positive. Recall, positive times negative, you get a negative. Negative times negative, you get a positive. Our example 3, 2y minus 3y squared minus 7y, then plus y squared. Now, the y squared is not a like term to y. I explained earlier that the powers of the unknowns, they are different. This y here has a power 1 and this y here has a power 2. So they are not like terms. So I'm going to combine negative 3y squared and the y squared here, then 2y and the negative 7y. So this is 2y minus 7y, then minus 3y squared, then plus y squared. When I do the operation here, I'm having negative 5y. Then when I do the operation here, I'm having negative 2y squared. My example 4, I'm going to add those fractions there. So the addition of fractions, remember when we talked about that topic of fractions, we had to get the LCM of the denominators, then multiply it on each term, and then simplify later on. So this is going to be the LCM of 3 and 5. That one there is 15. So I write my LCM there. then I come back here, I multiply it there, then I multiply it also there. So the 3 goes into 15 5 times. So this I'm going to be having 5a. Then here I have a 3 now times the b to get the 3b. So as simple as that, I've simplified that algebraic expression. My example 5, I have that there. So even these, they have fractions. I'm going to get the LCM of the denominators. LCM of 3 and 4 is a 12. So that's going to be my 12. Then times 12 here. Then even here times 12. So this one here is going to be 3 times 3 to have 9 into 4y minus 8x. Then minus the 3 goes into 12 4 times. So that's going to be 4 into the negative 3y minus 6x. Then now I'm going to open the brackets of the numerators. This one here is going to be 36y, then minus 72x, negative 4 times negative 3. We are going to be getting positive 12y, negative 4 times negative 6x. We are going to get positive 24x. Then there is still a division of 4. Now, looking at the like terms, 36y plus 12y, and then negative 72x plus 24x there. So when I add this to that, I have 48y, then minus 48x divided by the 12. Now in the numerator, there is a factor of 48. I can factor it out. So 48 into y minus x divided by the 12. The 12 is going to reduce the 48 4 times b4 into y minus x there. So I can leave the answer there, or some other person can have it as 4y minus 4x. Another person can first open the brackets here. That is this fraction times that there, and then that fraction times that one there. So 3 all over 4 times 4y, then minus 3 all over 4 times 8x. Then even here, negative a third times negative 3y, then minus negative a third times negative 6x. When you compute this one here, the 4 cancels out, so 1 times 3 times y becomes the 3y, then 3 all over 4 times the 8x, the 4 is going to reduce 8 2 times, then 2 times the 3 there, we shall be getting negative 6x. Then the 3 is going to reduce the 3, then negative 1 times negative 1 times y, we get positive y there. Then the 3 here is going to reduce the 6 again to get a 2, negative 2 times negative 1, then times x, we get positive 2x there. So you can see in this alternative, from the first step there, the second step, we have no fractions there. Then now I can collect the like terms. So that is 3y plus y minus 6x plus 2x. So I have to have, when I add these ones, I have 4y. When I add those ones, I have negative 4x. My example 6, I still have fractions there. We need to get the LCM of the denominators. The LCM is 12 times 12 there, and even here times 12. But here I'm going to put brackets there. When I simplify, 12 divided by 4, I get a 3. So 3 into x plus 1. Then here I'll be having a negative 4x there. So when I open brackets here, I'm having 3x plus a 3, then minus 4x divided by 12 there. Then 3x and the 4x, they are the ones that are like terms. When I add them, I'll be having a negative x, then plus 3 all over a 12. So my example 7, I still have fractions there, but this time round, one of the denominator involves an unknown. So I need to get the LCM there, then I try to simplify the numerators. So the LCM is going to be 3 times the x plus 2, or x plus 2 times the 3 there. So I get the LCM, I multiply it here, and I also multiply it there. So this is the 4 all over x plus 2, then times my 3 into x plus, then minus my third times 3 into x plus 2 divided by the 3 into x plus 2. So simplifying this one here, you can see that this is going to cancel with that. So I'll be having a 3 times a 4, and that one gives me 12. Then minus the 3 is going to cancel out with a 3. Then I'll be having that bracket of x plus 2, which is left. Then divide by 3 into x plus a 2. When I open brackets in the numerator, that's going to be 12 minus x, then minus 2, divide by 3 into x plus a 2 there. Now, the negative 2 and the positive 12, they are like terms, so I need to subtract them. When I subtract, I'll be having positive 10 minus x divided by the denominator, which is 3 into x plus a 2. Now, some students, when they reach such a stage, for them, they can start cancelling out the 3 with the 12 to have a 4 there. Then that person can cancel out this bracket and that bracket to have the 1 there, and this person can give you the answer as 4 minus 1 to have a 3. This is wrong mathematics. You cannot divide this denominator with the numerator, yet the numerator is still having an operation of subtraction. So whenever you see this, make sure that you don't do this wrong mathematics unless you are having multiplication. Like if I had 12 into x plus 2 divided by 3 into x plus 2. So this is where you can divide the 12 by the 3, because in the numerator the operation which is there is multiplication, and also in the denominator, the operation which is there is multiplication. But if it is addition and subtraction, you cannot divide those two there. So our example 7, we have 1 all over x plus y all over x squared minus x times y. We need to get the LCM. When you look at this denominator here, it has a factor of x, so I can rewrite it as x into x minus y. Okay? So since the x is appearing in this denominator and it is the same denominator here, then we are going to take the whole of this as the LCM. Because if I have 1 all over 2 plus 3 all over 4, you see that this 4 has a factor of 2, that is a half plus 3 all over 2 times 2, right? So here we end up taking the LCM as a 4 there. That's why even here we are going to end up taking this as the LCM of both these denominators there. So we have said the x into x minus y is going to be our LCM. So I'm going to come back and multiply it on that term there, and I also multiply it on that term. So this is my 1 all over x times the LCM, x into x minus y, then plus y all over x into x minus y, then times the x into x minus y. Simplifying this, the x is going to cancel out to have a 1, then times that bracket, which is the same bracket, then plus this bracket is going to cancel out with that bracket because they are the same. One is in the numerator, another one is in the denominator. So I'll be left with 1 times y, which is y, then all over x into x minus y. So negative y plus y is going to be 0y. Then I'll be left with x in the numerator all over x into x minus y. So the x in the numerator divided by the x in the denominator, they are going to cancel out. Then I'll be left with a 1 in the numerator divided by the x minus y.